comes to bounded integration by parts, it's the same process. We just evaluate both of them at the same time. So meaning, once we do this portion, we also evaluate this inner portion by b of a. Okay? So again, if we just use, so again, this portion we do double, so we're actually subtracting twice. So plug in b, and then minus plug in a, and then the normal integration by parts, and integration from there when it comes to it. So it's a little bit more work when it comes to when you have bounds, but again, it's not too difficult itself. Okay. So let's try this one out so you can see how these when it comes to bounds of integration by parts. So find integral from 0 to 1 of cotangent inverse, or cotangent inverse of x of x. All right, so this is kind of like with the natural log one. We're going to let u equal pretty much the whole thing. Okay, so then dv is just going to be dx. So integral of that is just going to be x. And the derivative of this, again, is just a property. It is negative 1 over 1 plus x squared. So this is du dx. Okay. All right, so now we've used our portion. So it's going to be, again, u times v, so this times that. Minus the integral of v du. So notice negative makes positive. This is integral, and this is evaluated from 1 to 0 of x over 1 plus x squared dx. Okay. So again, notice for the integration, we have to use a substitution rule. So let u equal this whole thing at the bottom. So therefore du is going to equal to 2x dx. And all we need is the x and the dx. So cut this in half. We get that. So this integral ends up being the integral from 0 to 1 of 1 over u du. And we know what that is, right? The integral of 1 over u is just natural log. So this ends up being natural log of u of that. All right, so plugging everything all in. So this is going to be x times cotangent of negative 1, or inverse cotangent, evaluated at 0 and 1, plus natural log of u, which was 1 plus x squared, evaluated from 0 to 1. Oh, with the 1/2. Almost forgot the 1/2 there. Right, that 1/2 goes right here. So it should have been there. And that's just plugging in the calculator, right? So plugging in 1, so cotangent inverse of 1, and then adding it to here. So this is going to be 2, so natural log of 2 cut in half. And that gives you approximately 0.364. And there we go. All right, let's try a couple more to give you guys more of an understanding of the integration by parts. Okay. All right, question 1 says find the integral of w squared e to the w dw. So notice, right, it doesn't always have to be x's. It can be any variable, but you're still applying the same concept here. Okay. So I'm going to let u equal w squared. Let dv equal e to the w dw. So this derivative is going to be 2w. This integral, good thing is, right, is just itself. Integral of e to the x is e to w is the same. All right, so therefore, it's going to be, again, v times u, so w squared e to the w minus the integral of v du. Keep forgetting that dw. Okay. Now, notice again, we have integration by parts. So the cool thing about, I guess the cool and bad thing is that you can keep doing this over and over and over and over again. And there's no other way to do this except for just integration by parts. So I'll try to make this a different color. Maybe pink will be nice so you can see the difference. Yeah, kind of different. Okay. So in this case, we have to do integration again, and we do the same process. So we're going to let u again now equal to w. dv is still going to be e to the w. So integral is still the same. Take the derivative. Now this is just going to be 2. Okay. So therefore, it's going to be from the first part minus v times u minus the integral. So minus makes a positive integral of 2 times e to the u dw. Crazy, huh? Well, kind of a horrible mess when it comes to it. Right? And now we just integrate this, which is the best part, is just e to the w, right? Because that just goes away. So our final answer is just w squared e to the w minus 2w e to the w plus 2e to the w plus c, right? Don't forget a constant. And there we go. So sometimes when it comes to sines and cosines, you actually may have to do this 3 times, which is again a really, really, really bad situation when it comes to it. All right, let's try last one down here. All right, so find the integral from 0 to 1 of x squared plus 1 times e to negative x. Okay, so can already tell how we're going to break this apart, right? So let u equal x squared plus 1. du is going to be e to negative x dx. So derivative here is going to be 2x. Integral here is not as fast as the top one, right? So let's see, if we take the integral of e to the negative x dx, that is also again a substitution rule. So just pop a negative and we get exactly what we need, right? So this ends up being negative integral of e to the u du, so it's just negative e to the negative x. So this is this one right here, like that. Okay. All right, so now we plug it in. So we're going to have v times u. Oh, don't forget the negative in the front, so I'll just pop it up here. X minus the integral, so minus makes positive, so plus the integral of 2x e to the negative x dx. Uh-oh. Guess what? More integration by parts. So same concept that we just did above. So again, we have to do another integration by parts because of here. So we're back to square one essentially, right, when it comes to it. Okay. All right, so therefore, do it again. So let u equal 2x. dv is going to be, again, e to negative x. This is going to be a 2, which is nice, so probably going to stop here. So imagine if this is like the fifth, x to the fifth, we would have to do this 4 times to actually get the entire integral answer, which can be pretty crazy, right, when it comes to it. All right, so the good thing is we know what this integral is going to be because we just did it. So we save some time there. All right, so according to this integral, it's going to be, again, this times this. So it's a plus, so we're going to have this times this. Minus the integral, or plus makes minus makes plus, integral of this times that. Okay. Lots and lots and lots of work. So now finally, this integral isn't bad because again, we've already done it. So our overall portion is going to look like this. So this integral is essentially that one just with a 2 in front. And this is all evaluated from 1 and 0. A bunch of horrible mess. So that means you just plug in 1. So 1 squared gives you 1. This is negative 2 e to negative 1. Plug in 1. This is negative 2 e to the negative 1. And this is, negative 2 e to the negative 1. Notice, so we could put those together. So essentially, after all of this, mumbo jumbo, and then just plugging them in, you get something like this out as your final answer. Right? Because if you plug in 0, all these e to the x ends up being 1 itself, so it's just 1. So negative 1 minus 2 minus 2. Or this actually goes away, so negative 1 minus 2 there, because you negative 3, and ends up being canceling stuff out when it comes to it. Okay. So that's roughly what you get if you plug it in and just slowly simplify, or just plug it in a calculator itself. Okay. And that is integration by parts.